Okay, the next topic in section 4.1 is absolute and local extrema. So, extrema is just a sort of a general word that means maximum or minimum, kind of like the word sibling can mean brother or sister. So, we're going to look at how to find extrema in this section. And there are a couple of different types of extrema. There's absolute, and then there's local extrema. Local are also sometimes called relative extrema. So I want to go through these two definitions, or I guess this is technically four definitions, but I want to go through those. But before we do, I just want to look at an example because the definitions are fairly intuitive, and I think it'd be better to start with just an example. This function right here, if you look at it, the absolute maximum is the highest value of y that the function attains. So that's going to be right here. So the absolute max is it's the y value of this point. Looks like that's 2.75. Now this value here is a local max here. Local maxes, you can think of them as being like a hilltop. So that's a local max, and this over here is the absolute max. It's also a local max. Now down here we've got the local min, or a local min. That's a local minimum because it's a valley. But this function has no absolute min. And that's because there's no number you can say this is the lowest value of y that this function attains, because it goes down forever. And you wouldn't say that its absolute minimum is negative infinity, because negative infinity is not a number. So we just say it doesn't have an absolute minimum. And let's look at the definitions. Let's see. The difference between the absolutes and the locals is the last bit here. On the absolutes, it talks about for all x in the domain. And down here, for the locals, it just talks about when x is near c. So what this absolute maximum says is, if c is a number in the domain, then f of c is the absolute maximum value of f on D if f of c is greater than or equal to f of x for all x in the domain. And for local maximum, for local maximum, it just says when it's near. So let's do a few more examples of this. The function f of x equals x squared. Now we know what that function looks like. Let me draw it. If we do this, it has a local minimum at x equals 0. And I'm going to put in one more thing. It has a local minimum of 0 at x equals 0. So notice this right here is the y value, and x equals 0 tells us where it is. So this has a local min of 0 at x equals 0. And this is also a global or absolute minimum. And this thing has no local or absolute maxes. I guess the correct way to say it would be no local or absolute maxima for the plural. All right, now this next one though, y equals minus x cubed plus 4x. Let's graph that one and see what it looks like. Okay, We know the basic shape of cubics. Well, let's see. X cubed, okay, I'm missing a negative there. If I put that in there, then we see this function here. I'm just going to do a quick copy of it up here. So this has a, I'll do this in a different color. This is a local max, and this is a local min, and it has no absolute max or min. Now, if we wanted to find those, where these local max and mins are, what we'd have to do is take the derivative of this function. So I wasn't planning on doing that on this one, but let's go ahead and do it. All right, so let's find the coordinates of this local max and local min. Let's see, y prime is going to be minus 3x squared plus 4. If I take that and set it equal to 0, I get 3x squared equals 4. If I move it over, so you get x squared is 4/3. So x is plus or minus square root of 4, which is 2, over the square root of 3. So that right there tells us where these max and mins are located. So if I just grab my calculator, I mean this is the this is exact. But if I take my calculator and I put in square root of, well, let's see, 2 divided by square root of 3, I get 1.1547. And if we look at this on Desmos, if I look at this, yeah, 1.155. That's one of them, and the other one is the same thing but with the positive. So anyway, that gives us where they occur. So this is at 2 over root 3, and this one is at negative 2 over root 3. And I'm perfectly fine with you leaving square roots in your denominators. They don't bother me at all. We'll do some more examples of finding maximum and minimum values in a bit.